Good morning, everyone. I'm Amira Eltahan. I'm a PhD candidate at the University of Alberta, and I'm supervised by Dr. Farook, Hamzeh, and Dr. Gaang. Both are professors at the UFA as well. So today I'll be talking about how task complexity impacts cognitive load in dynamic tracking tasks. So 28,512 is the number of lost time injuries reported in 2022 in Canada, as reported by the Association of Workers' Compensation Board. So can you guess what are the top causes of that? So that was my second question. After we saw this number, we wanted to investigate more about what are the top 3 causes that were published in this report. So the top 3 causes are, so they are struck by an object, struck against an object, caught in or compressed by equipment or object. Can you guess what, can you notice anything in common between the 3 causes? Okay. So what we notice that they have in common is that they all relate to situation awareness, missing cues. So you're missing some cues, or you're not aware of your surroundings. So you're either like struck by an object, you're caught between equipment or stuff like that. And all of this relates to something called dynamic tracking. So you are in a dynamic environment. There is dynamic objects moving around you, and that hinders your performance or your safety awareness and your situation awareness as well. So I want you to imagine that you are operating this excavator. It's hot or it's cold, like in Edmonton as usual, and you're under like heat stress or cold stress, and you're shuffling a lot of information. You're you have a lot of people moving around you, a lot of equipment moving around you, and you're working under stress. And there is a certain productivity rate that you're expected to achieve by the end of the day. All of these stressors are maxing out your cognitive load. But what if we can actually measure this in real time to allow for timely interventions? And thankfully, our scientists developed something that can actually measure cognitive load in real time. And this is where this research comes in. What we're trying to do is we're trying to explore how task complexity, so the different environments that we're in specifically in construction, it's a visually demanding environment. It impacts our cognitive load and how this affects our performance in return. And we need to derive some insights to improve construction workflows. And how we're doing this, we're leveraging the use of wearable sensors, specifically the eye tracking, because they are site-friendly. So how I'm doing that, we're adopting the design science research. So first thing, we started by identifying the problem. So according to literature review and industrial consultation, that we reached the conclusion that there is a problem of dynamic tracking or situational awareness in construction site, given how dynamic the site is. And then designing the solution, we did a within subject lab experiment for dynamic tracking tasks. I'm explaining this in the next slide. And then evaluate the solution. We want to see how eye tracking metrics or the eye tracking metrics are related to performance and related to our cognitive load and task complexity as well. So we have 3 elements that we're studying: the task complexity, cognitive load, and their impact on the performance. So for the controlled experiment design, we first started by a task design. So we did 3 identical tasks of varying complexity. So we coded like a video of a very simple moving dot at varying speeds, and we asked the participants to track it as accurately as they could. Very simple, but we'll see how interesting the results were. And then they wear the pupil invisible eye tracking glasses, which have a scene camera attached to it, and it does gaze mapping between their gaze and the video that they are shown. And finally, for data analysis, we did the Pearson correlation coefficient between the eye tracking metric, the performance, and task complexity to see if there is a significant link between them or not. So here's in figure 1, you can see the scene video captured by the eye tracking glasses. And in figure number 2, we can see one of the participants wearing the eye tracking glasses in our lab setting and performing the experiment. So what about the metrics? Which metrics did we calculate that for? So we have 5 different eye tracking metrics. So for the saccadic, we have the saccadic peak velocity, saccadic amplitude, and saccadic mean velocity, which is a very sensitive indicator of cognitive load. We also have blink rate and fixation rate. And for the performance, we measure that by the radial distance between the actual coordinates as coded in our video and the gaze coordinates that were recorded through the gaze mapping through the eye tracking glasses. So let's go for the results. So the question is, does the first part of the question, does the visual complexity impact cognitive load? So, for example, you can see here the saccadic peak velocity, it declines as the complexity increases, and saccadic peak velocity is a classic indicator of cognitive load, and this actually participants followed the typical behavior of humans when they are exposed to heightened complexity, and this confirms our theory that yes, dynamic complexity, tracking complexity does impact the cognitive load, and it heightened it. And also this was confirmed by the saccadic amplitude, and here we can also see a classic behavior when humans are faced by different complexities. The amplitude increases, which is the angular distance of the saccades. So usually we try to scan like a wider space or a wider area when you are exposed by heightened complexity, and also it confirms our first hypothesis. And the third one, which is the blink rate. So usually when you're under stress or you're under heightened complexity, you tend to blink less. And we can see that the 7 participants exhibited the same behavior across all the tasks. So we're not very interested in the value itself. We're mostly interested about the trend, because usually everyone will have a different blink rate depending on his eyesight and his individual characteristics and so on. So what about the performance? So now we measure task complexity and the cognitive load. This is the first 2 variables. The second one is the performance. So my performance here is measured, as I said, by the tracking error. So the higher the error, the worse the performance. So we can see that we have higher error as the complexity increases, which also confirms that dynamic tracking complexity actually leads to less worse performance. So what does that mean for construction workflows? So we need to focus on reducing task complexity. And I know I'm saying this as if it's something like very easy or very static. And this is also part of my ongoing research, is to quantify task complexity. What do we mean by task complexity? Because it means different things in different tasks to different instances. Like every task is dynamic, so it evolves as the execution progresses. And we acknowledge that, and this is part of the ongoing research to address this. And also we need to enhance training for high complexity tasks. So we see that as the complexity, visual dynamic complexity increased, the performance was reduced, which confirms that we need to enhance training for these high complexity tasks, specifically when there is a high risk, for example, people with machine operators and stuff like that. And we need to design the visual environment. So we usually focus on designing the task itself, but we don't really care, we don't study much the environment of the workers, how the speed of the moving equipments, how many equipments are moving inside, because this is when accidents happen, because a worker failed to notice moving equipment or a moving object nearby. Also, we need to leverage wearable sensors, because if we did that, we could enable what we aim to, which is enable real-time cognitive load monitoring on construction sites. And for this research, we use eye tracking glasses, which is site-friendly wearable sensors. And actually, we are deploying it on an active construction site in Alberta very soon. And also we need to monitor the worker performance, so adjust the workload. So if the workers have these wearable sensors on while performing a task, we could enable real-time adjustments of the workloads and real-time rest breaks in the workflows when they are experience fatigue and so on. So what about the limitations and future work? So definitely we acknowledge the individual differences, and there is a limit to generalize the findings because of the small sample size and the controlled experiment. And also, it's a very simplified representation of the dynamic environment of the task, and we're addressing that by doing a secondary stage of this research, by doing a VR experiment for the dynamic equipment like that mimics a real construction site. And also, we can include other cognitive load indicators such as the pupil dilation or heart rate variability. So to conclude, in this paper, we address the impact of complexity on eye tracking metrics, how workers respond to visually dynamic tasks, and some recommendations to reduce to improve their accuracy and their safety. And also, we offered a foundational understanding of cognitive and visual demand on the worker performance. And these are my references. And thank you. If you have any questions, I'm happy to.